So today I'm working on RFID readers. So the technology behind the RFID reader is called radio frequency identification. So basically how RFID works is that it uses electromagnetic fields to automatically identify and track tags attached to objects. And in order to do that, the system needs two components. The reader, which emits a radio frequency signal that powers up the RFID tag when it gets close enough, and the transponder or the tag, which stores data like an ID, and once powered, it sends this data back to the reader via radio waves. And these tags can be either active tags, which means that they are powered by their own, or they can be passive tags, which means that they are powered by the reader's signal. A popular RFID reader is the RC522. It is used for passive tags. So what happens is that when the RFID reader sends out radio waves, it creates an electromagnetic field. Passive tags don't have power source, so they rely on this field by having a coil inside them. So as the tag enters the reader electromagnetic field, this coil inductively picks up energy from the radio waves and uses this energy to power a microchip inside the tag, which sends the stored data. The RFID detects these signals and decodes them to retrieve the information stored in the tag. So this process happens wirelessly and nearly instantly, noting that RFID systems use different frequency bands for communication, so the frequency used affects the system's range and speed, meaning that the higher the frequency used, the longest read range and the highest data transfer rate is achieved. So now I have a RC522 module. Here's how to interface it with Arduino. I will connect the SDA or slave select slot on the module, the digital pin number 10 on the Arduino, the SCK or serial clock slot on the RFID, digital pin number 13 on the Arduino. We connect the MOSI, master out slave in, to the digital number 11 on the Arduino, MISO or master in slave out to digital number 12 on the Arduino. RIQ slot will be unconnected, the GND to GND, the reset to the digital number 5 on the Arduino, 3.3 volt to the 3.3 volt on the Arduino. Now in the Arduino IDE I have already installed a library used for RC522 communication. So in my code right here, what this code will do is a RFID based access control system using an Arduino and an I2C LCD and a servo motor to simulate a door opening and closing. And I have multiple tags and each one of them have some pieces of information stored. There is a key data that the system uses to recognize a tag when reading it, which is called a UID or a unique identifier for the RFID tag. So I have a bunch of tags, but I will set only one of them as the master or the primary tag, which will have control over the system, and I will include it in my code. So first I included these necessary libraries for the project: wire and liquid crystal I2C.h for the LCD display communication via I2C, SPI for communication with the RFID reader, RC522 for controlling the RFID module, and servo.h to control the servo motor. Next, I have defined the pins to set up the connection between my RFID module, the servo motor, the Arduino, SS or slave select pin, and reset pin for the RFID, and the servo motor is controlled by pin number 3. Then I have declared some variables. Byte read card, this is an array to store the RFID card's unique ID. Master tag is a string containing the authorized tag's UID. So this is a UID for a card tag I have, and I was able to get this UID from the getID function. And tag ID will store the UID of the currently scanned tag for comparison. After that, I created instances for the RFID, LCD, and servo. And in the setup function, I have initialized the LCD, initialized also the RFID reader and the servo motor. In the loop section, the while loop keeps checking for an RFID tag because the getID function detects if a new RFID tag is in range. If no card is detected or the reading fails, it returns false. If a tag is present, it reads its UID and converts it to a string and return true. So if the scan tag matches the master tag, I cleared the LCD and displayed access granted. And the servo motor moves to 90 degrees to simulate the door opening. And after a 1 second delay, it moves back to close. And if the scan tag do not match, I cleared the LCD and displayed access is denied. And after processing the tag, the LCD is returned to its initial state in order to scan the next tag. And that's basically how I built this simple RFID controlled access system with an LCD and servo motor.